In this session, let us understand about the p-value. Before going to the definition of p-value, let us understand the null hypothesis. Null hypothesis assumes that there is no effect or no relationship between variables. Alternate hypothesis is the opposite of the null hypothesis. Let's see a few examples of null hypothesis. Music has no effect on concentration time. That is the null hypothesis. And the alternate hypothesis for this is music extends concentration time. Null hypothesis states that pollution levels do not affect fish survival. Alternate hypothesis is higher pollution reduces fish survival. There is no correlation between homework time and GPA, that is the null hypothesis, and there is a significant correlation between homework time and grade point average, that is the opposite of the null hypothesis. Having understood about the null hypothesis and alternate hypothesis, now let's see the definition of the p-value. P-value is defined as the probability of rejecting the null hypothesis. A smaller p-value indicates stronger evidence against the null hypothesis. Generally, for the p-value which is less than 0.05, there is a strong evidence against the null hypothesis, and hence the null hypothesis has to be rejected. For a greater value of p, which is greater than 0.05, there is a weak evidence to reject the null hypothesis. So in such a case, it is not possible to reject the null hypothesis. Let us understand the p-value further by taking an example. By considering a score of 60 students in a class, for that we are generating a normal distribution with a mean value of 50 and standard deviation of 10, and we are generating 60 scores of the students. So class score equal to np dot random dot normal. 50 is the average value and 10 is the standard deviation and 16 is the number of values that we are generating. So this is the output which gives the scores of 60 students. Now let us consider the null hypothesis is it is common for students to score 68 marks in mathematics. Now we have to decide whether this null hypothesis has to be rejected or it should not be rejected. For understanding that, let us see the two in stats in Python, stats.norm.cdf of z-score for the given z-score. So CDF is the cumulative distribution function which gives the cumulative probability, which is the area under the normal distribution curve to the left of a given z-score. Let us assume that this is the given z-score. So in such a case, stats.norm.cdf gives the area under this entire curve. On the other hand, 1 minus stats.norm.cdf gives the area which is to the right of the z-score. So this area, which is the dark area, so which is towards the right of the z-score, which is the probability of getting a value greater than the given z-score. So this is about the two functions stats.norm.cdf to get the area under the curve, which is to the left of the given z-score, and 1 minus stats.norm.cdf, which gives the area which is towards the right of the z-score. So this is the probability of getting a value which is greater than the given z-score, which is the 1 minus stats.norm.cdf, and stats.norm.cdf gives the probability of getting a value which is less than the given value of the z-score. Let us move to the code. So let us see the example of p-value. Here we are generating the scores of 60 students in the subject of mathematics. So this is the example of the p-value. Here we are generating the scores of 60 students in mathematics with a mean value of 50 and standard deviation of 10. Now, according to our null hypothesis, which states that it is common for students to score 68 marks in mathematics. Now, let us find the Z score corresponding to 68 marks, which gives the formula for which is Z value is computed by using the formula x minus uh, mean divided by standard deviation, x minus mu by sigma, which is x minus the mean value divided by standard deviation. So Z score is given as 68 minus the mean of the class score divided by the standard deviation of the class score. So the Z score corresponding to 68 is now 1.96. Now let us find out the p-value corresponding to the null hypothesis, which states that it is common for students to score more than 68 marks. So since we are interested to find the area under the curve, which is towards the right of the Z score corresponding to 68 marks. That is why we have to use the formula 1 minus stats.norm.cdf uh, and we have to pass the Z score corresponding to 68. So now the p-value is 0.02. So corresponding to, if you convert that into percentage, which is 2.47%, which is less than 5%. 5% is the significance value. So since the p-value, whatever the p-value that we got is less than 5%, it means that the null hypothesis can be rejected and it can be said that it is not common to get 68 marks in mathematics. Since this value 0.024, which is less than 0.05, it assumes that the p-value is less than 0.05, and since here we got the p-value which is 0.024, which is less than 0.05, indicates that the null hypothesis has to be rejected. So there is no evidence of proving the null hypothesis. Hence the null hypothesis has to be rejected, which means that it is not common for the students to score more than 68 marks in mathematics.